All right, perfect. Let's go ahead and let's get started. Today, our core focus is everything you need to go into production with Kubernetes. I plan to give a little bit of a slideshow presentation here and a pretty quick high-level overview of some of the solutions that we have. And then Kasten will show you some of their solutions as well too, with some of their product slides as well too on how to do data protection, backup and recovery services at an enterprise level for Kubernetes. So let's talk about the agenda. What are a couple things that we want to talk about today? Well, first off, I want to talk about what are some of the common challenges that we see people are facing when going into production with Kubernetes. As we know, Kubernetes is an open source platform. And when you look at Kubernetes, it's a great platform to run your microservices. But at the end of the day, it's a low-level compute resource engine, and it's built and designed to do long-running tasks for your microservices, your containers, and include some stateful services as well too. What other Cncf cloud native computing foundation tools are necessary for a deployment in production, right? When you get Kubernetes, it's just a platform, but you got to integrate so many other ecosystem components. You got to think about monitoring, logging, networking, storage, data protection, backup and recovery, a lot of other things you got to think about that you got to integrate into that platform. We'll talk a little bit about how D2iQ and Commander integrate all these tools, and then how you can protect Kubernetes and the applications running on it with Kasten and K10. So what really kind of drove the market to this new paradigm is, if you kind of take a look back over the last decade and a half, we've been really kind of in a virtualization world. And inside that virtualization world, we saw huge benefits, right? I can quickly, take a server and run multiple servers on it. I can create VMs. I can do it faster than I can do bare metal. It allowed me to be more agile, but you were still coupling your application to an operating system. And then things slowly started migrating over to containers or microservices, where now, hey, I've taken my application, I've decoupled it from the operating system, and all that's running in this container are the necessary daemons that I need, binaries, to run that application. And we see great benefit from it, right? They're lightweight, they're portable, right? I can migrate them a lot easier. It's easier for me to update the application. I've decoupled it from the OS, a wealth of benefits that it provided me. And we saw a lot of people starting to say, hey, I'm using Docker, and we're running these Docker images. Next, as you started to scale that environment, you kind of sat back, you know what, I need a platform. I need something to run it on. People started off with either Docker or Mesos, and then Kubernetes kind of came onto the scene, and it's kind of become that de facto standard now today as a platform to where we start running a lot of our containers. And as you started putting containers more into a Kubernetes environment, it introduced other open source tool, other cloud native capabilities and methodologies we had to think about. And shortly after that, you start having a lot of Kubernetes clusters or microservice platforms, whether that be do it yourself, in the cloud, multiple different other types of open source tools that we integrate, and we start to see a proliferation. And at times it can be a little bit more difficult to manage. But what was driving all of this change was a lot of companies saw huge benefits in doing this. They saw business outcomes as a driver. Well, one of the first tenets that we see is, why are people moving to containers and things like Kubernetes? Because it gives them the capability to have faster deployment. Lines of business always want us to respond faster. Get me to time to market faster. It gives me competitive edges over my competitors if I can release services and goods faster than they can. So I can deploy faster and respond to business. Improve scalability. When you think about, as I mentioned, in that virtualization world, when I worked at VMware and I was a VMware architect, we used to always have to scale up to meet load during, Q4 to deal with Black Friday, right? Build us 100 virtual machines and we'd spend weeks doing it, integrating into our DNS, load balancers, etc. Well, with containers, it's just so much easier for me to be able to scale it, right? I have one Nginx, right click it, scale up to 10, and now I've got 10 containers and they're all load balanced. So customers say it allows me to be able to respond to business faster and give me greater efficiency to improve my scalability. And then finally, cloud portability. I mean, we live in a world now today where it's all about hybrid and not just on-prem. So, hey, I need these containers and I need my Kubernetes platform to be, portable, lightweight. I want to be able to migrate applications. I want to have that agile and flexibility to have true cloud portability. And that's what's driving a lot of that adoption. But as customers start embracing Kubernetes and they start saying, Well, what do I need to make it enterprise ready? What do I need to make it production ready and put it in a production readiness state? We asked, like, what are the most common challenges that you see? Now, I put a box around the most common challenges. I didn't put the one over on the left, as you can see, is more of a people process issue, cultural challenges with development team. But when you start thinking about it from a technology perspective, customers are concerned about, well, I got compliance and regulatory standards I have to adhere to, so security. How am I going to secure this platform? It's more complex. It's more complex than what we've been doing. Is my team and my staff trained and ready to take this initiative on? So I'm concerned about lack of training. And then you start moving down the scale and you start moving into the actual tech away from people process. And it's, how do I do monitoring? How am I going to do networking, storage, logging, service mesh, right? So these are things that resonate in the market to say, how are we going to address this? How are we going to support these challenges? So let's think about logs and monitoring, for instance. Once you get a platform up, before you can move anything into production, the first thing you need to ask yourself, well, what do I need to monitor? Well, I need to monitor the application. I need to monitor the platform. I need to monitor for workload optimization. Am I using my resources effectively? Am I over or under provision? How am I going to troubleshoot and debug? So you sit back and you go, well, I need to monitor as many components as possible. And when you start thinking about Kubernetes, you got to think about, I got to monitor the Kubernetes core services, and then all the add-ons I'm going to have to integrate. Elasticsearch, Kibana, your storage, if you're going to do things like storage. I need to monitor for data services, for complex distributed systems I may run, like Kafka, Spark, or Cassandra. And what about my application delivery pipeline? These are all things I need to integrate, monitor, so I have visualization, logs, so I can correlate issues, and then use a debugging tool to help me fix these problems. So you sit back and you kind of say to yourself, well, which monitoring, if we're going to kind of do Kubernetes, I'm going to go out to the Cncf landscape, see which ones are cloud native certified. And these are all the different logs and monitoring tools that you can leverage to integrate into your Kubernetes. Now, the first thing most people ask themselves, well, which one is the most popular, best in class, best in breed? How do I choose the right solution? Code abandonment is a real thing. And so I don't want to pick something that's going to maybe be gone in a year. How many contributors are in it? How many people are actively using this in production environments? So you try and make the best decision, choose the right solution, and then your next focus is, let's start integrating this into our Kubernetes platform. So the most popular 4 that you're going to find in logs and monitoring in the open source community are going to be Prometheus, right, which allows us to be able to scrape for alerts, Elastic, Kibana, which gives me Elastic for all my logging, Kibana to give me the visualization, and then Grafana also to give me visualization for all my dashboards, so I can see an overview of health, performance, where issues may be happening. These tools allow you to be more proactive versus reactive, and these are the most common tools that we see today in the market that are integrated into the Kubernetes ecosystem. So what are other things I got to think about? Well, I need to think about data protection. I need to protect everything. If I have stateful services in my Kubernetes cluster, I need not only to protect the cluster state, but I also need to protect my application data. Now, when you think about Kubernetes, a lot of people use Valero. Valero is a tool that's only going to back up the cluster state. But as you start thinking about, how am I going to provide disaster recovery? How do I provide data protection, backup and recovery? And how do I protect all my application data? This is where Kasten is going to come in and show you how they provide these true enterprise capabilities. But these are the next evolution of things that you're going to be thinking about. So as you start that journey, you start asking yourself, well, should I build my own Kubernetes platform? Should we invest into it? And we want to go completely open source. So I need to think about continuous integration. I need to think about application and definitions, like integration with Helm charts. I need streaming and messaging capabilities. I need debugging, observability, and analysis. All of these are the tools that you can leverage that are cloud native to integrate into your Kubernetes ecosystem. So when you look at the map, it can be absolutely daunting, right? Other things I got to think about as well too are, well, what about my container registry? How am I going to integrate security and compliance? How do I provide key management for crucial data services that I want to be able to protect and encryption? These are things that you're going to sit back and think about, and then your team's going to have to integrate into that Kubernetes ecosystem to make it truly enterprise grade and production ready. So let's think about how hard can that be at times, right? It can be difficult to keep up in securing that environment, right? You know, we just kind of went through that whole list of things that you can choose from. Well, what happens after I do choose them? I got to think about what vulnerabilities do I have to patch? What other updates do I have to integrate? So when you look at this chart here, this is based on just from December 28 to June 2019. And when you look at some of the core components that people have chosen, these are things that they've had to deal with. I've had 37 vulnerabilities and I've had over 187 releases. That's upwards of 5 upstream releases per week. I have costs to go through build, test, scale, and I've got a lot of full-time engineers that just focus on these types of capabilities. So the cost gets relatively expensive, and it can be difficult at times to say, these are things that we literally have to think about from a change management perspective to make this enterprise ready, right? So then the next question becomes, well, should we just choose a cloud provider? Should we think about that, right? Let's just take all of that hard work away, and do we go with a cloud provider? But then the question you ask yourself is, well, what am I going to get with a cloud provider and what aren't I going to get? So obviously one of the pros, and we all know this, we've been seeing this for years, lines of business go out to AWS, Google, or Azure because they can get services ready in minutes, and they've got a pay-as-you-go model. The cons with that is sometimes that's not always allowed. One that I should have put in here is sometimes you have proprietary lock-in. Take time to support new versions. If any of you have ever gone out and done EKS or AKS, you only get a specific set of versions. They typically only have like 3 or 4 different versions that they'll support. That's it. So sometimes you may be, I need that feature, but it's not available in the cloud provider. So those are sometimes issues that you got to deal with. Weak user experience, limited support, and then no focus on day 2 operations. When you go spin up some of those cloud solutions, it's just Kubernetes, that's it. They don't have the monitoring, the logging, all the storage. Those are other services that you have to choose from the cloud provider to integrate, or integrate some of your own solutions as well too. So not always as easy and simplified as it looks, even when you're thinking about it from just a day 2 operational perspective. So let's talk then about what D2iQ Convoy provides. We saw these as challenges in the marketplace, and we wanted to address them. Well, the first thing that we wanted to do is we wanted to build a Kubernetes distribution that had no proprietary API or CLI. And we wanted to focus on ensuring that we also integrated it with all the day 2 add-ons that you need to think about. As I went through that entire list, and it was probably difficult to read, but that's how many different options you have, we've made some of the best choices, we believe, best in class, best in breed, and integrated them and automated it fully into the Kubernetes distribution. This is where D2iQ Convoy comes into place. Our core focus was to build it on industry standard provisioning methodologies and full automated configuration management. We wanted to think about all the stuff you needed from day 2, monitoring, disaster recovery, DNS, ingress, open policy agents, and service mesh, so you have policy configurations, and logging. Now I'm going to get into each one of these here on the next slide, but one thing that we also wanted to ensure as well too is that we were also a cloud native certified Kubernetes partner. We provide both service provider services, and we also provide training, essential training services as well too. Whether you want to be a CKA, CKD, we do train the trainer. We have whiteboard and reference architectural classes. How do I move from Docker to Kubernetes, etc. But let's talk a little bit about how we built this cloud native. The first thing we wanted to focus on was infrastructure automation. Obviously, a lot of people know that Cluster API is an up and coming thing, but it's still very much in its infancy. And Cluster API doesn't work across all cloud providers. So we chose to build the platform on top of infrastructure automation that is widely adopted, using Terraform to automatically provision your cloud resources, and then Ansible to add on all the day 2 configurations or for your on-prem installations. The second area we did is we used raw vanilla Kubernetes. As I mentioned, we did not want to take and build a proprietary platform that uses proprietary APIs and CLIs. We use Kubernetes. It's all back-ended by a key value store leveraging etcd, and all the automation built into all of the Kubernetes is done via kubeadm. Then we looked at core add-ons. Well, what add-ons are you going to need in order for you to be successful? Well, I need to be able to have network policies. So we've incorporated Calico. I want to be able to publish application catalogs leveraging Helm. I have traffic for ingress, container storage interface, right? I'm going to have stateful services, so I want to be able to use a storage provider. Core DNS and Valero for Kubernetes cluster level backups. Then when you look at the far right, we got our monitoring and logging solutions. As I mentioned earlier, we did grab the most popular methodologies for logging, monitoring, troubleshooting, and debugging. The platform comes with Prometheus, Grafana, Telegraph, Kibana, Elastic, and FluentBit. Now, one of the other things that we did is when you think about this is, well, if I were to do this on my own, I would need to go out and get commercial support. And a lot of times that can lead to procurement fatigue. Well, which solutions do we choose? Which ones do we feel our team is not up to snuff on that we may want enterprise support for? I can't buy them all, it'd be too expensive. One thing that we do at D2iQ is this complete validated and tested reference architecture is all fully supported. So if you invest leveraging D2iQ's Convoy's Kubernetes distribution, you get support for this entire stack, all of the components. The far right are swappable. You can swap these out if you were a shop that, hey, we use Splunk, we don't want to use Elastic. It's as simple as just turning that feature off in the YAML file and it won't deploy. So we've also made it very modular so that you can pick and choose components that you want as well too. But these would be the components that we would provide full enterprise class support for. One of the other things that we pride ourselves on is we do want to make sure that they're tested and validated. So all of the applications, all the add-ons are certified to work with one another. And one of the other things that we do is we actually scale test it. So before we release this into the public and provide our next version, we go through our soak testing and do a scale test, mixed workload test as well too. Our last test, we did over 40,000 pods, over 500 Jenkins masters, 6 million messages into Kafka, 2.8 million writes, over 4 data centers with Cassandra, and 1,000 jobs and 50 instances. One, we want to make sure that the platform scales to meet what we say it can meet. Two, we also want to ensure that, hey, we're checking for bugs and squashing bugs as well too when we do our mixed workload testing. And also we want to make sure before we integrate any other new package into the mix that we've proven that it can scale to meet its needs as well too. So let's talk real quick then about how am I going to manage Kubernetes if I have multiple Kubernetes, right? We live in a hybrid world now today. We also know you're not going to have just do-it-yourself Kubernetes clusters. You're probably going to have some EKS, AKS for specific lines of businesses. You're going to have a mix in the world today. Well, today in Kubernetes, if you were to do that, you'd have to manage each instance separately. One of the things that we went out to do is also build a universal control plane that allows me to be able to manage multiple Kubernetes instances. We wanted to be able to give customers the ability to have consolidated multi-cluster governance. We wanted to help them simplify their operations management and give IT teams the right roles and responsibilities to what they may need to do in a Kubernetes environment. Let's talk about how that would look like. Well, one of the things that Commander went out to do is we really looked at 5 key tenets. If I'm going to bring all my Kubernetes into a single pane of glass that gives me universal control, a universal control plane, and allows me to focus on automation service delivery, we wanted to ensure that 1, we can push out security using build policy as code. If I have 5 Kubernetes clusters, I just want to be able to invoke and push my security roles directly to those clusters, set cluster roles and responsibilities. We wanted to also be able to ensure that, hey, I have multiple Kubernetes clusters. I want to standardize all my monitoring alerts. I want to bubble all of my metrics, all of my telemetry data into a single dashboard. I don't want to measure and monitor each one individually. I don't want to manage alerts individually per cluster. Give me a centralized location to manage all of my alerts, all of my monitoring from a centralized single pane of glass. The third thing we wanted to do was be able to give you financial visibility, chargeback and showback capabilities. One of the big things that customers are trying to figure out now today, hey, is it more cost effective for me to run this in AWS or on-prem? Did we right-size this environment accordingly? Are we over provision, under provision? I want to be able to track some of my costs so that I can also make better educated guess to what I may need next year or what this type of service and application actually requires. The fourth one is we onboarded organization with single sign-on capabilities. Right? I want to be able to use OpenID Connect. I want to be able to use LDAP or GitHub. I want to integrate my users and groups so that I can assign them to the right cluster policies, roles, and responsibilities. And then finally, giving you the capability to have workload scalability. I want to be able to scale mission workloads. So if I see that, hey, I am running low on kubelets, I need more kubelets, with a single click of a button, I can automatically add another kubelet. Or I'm running Kudo, Kubernetes Universal Declarative Operator, and I'm running Kafka, and I have 3 brokers, but right now I feel like I need 4 or 5 brokers. I want, with a simple click of a button, be able to automatically scale that application. And not just scale it, I also want to be able to upgrade it and provide full service delivery and application lifecycle management to it. That's what Commander brings to the table. And it's not only for our Kubernetes clusters. This supports EKS, AKS, do-it-yourself, Rancher, other types of distributions as well too, giving you full centralized management capabilities. So what are some of the pros versus some of the cons? Well, obviously one of the pros we feel is it's fully automated. With a single click of a button, I can have an entire Kubernetes cluster up with leveraging that Terraform and Ansible. It's just Convoy up. It automatically reads that cluster.yaml, provisions it, whether it's on-prem or in the cloud, wherever that platform of choice that you want to deploy it. It's just a single click of a button, Convoy up. Quickly support new versions. And that's one of the things that we're priding ourselves on as well too. We don't want to be in a cloud provider situation where we only say, we're only going to allow you to run these 3 versions. We want to be able to iterate as fast as possible, integrate and certify Kubernetes for all the core add-on packages. The third one is we made it very heterogeneous. We want to allow you to be able to deploy this anywhere, whether it's on cloud, in the prem, deploy anywhere on any platform, provide good user experience, give you premium support, and everything you need to ensure that you can run a production-ready, enterprise-grade with all the day 2 operation capabilities that you need. So Commander, we've also do mixed workload testing and verify that it's built to scale, supporting up to 95 clusters, 76 workspaces, which I'll get into in a little bit for lines of businesses, 20 federated clusters, supportability across multi-cloud Kubernetes instances, and also supporting multi-region. So let's go into a little bit of a demo. I'm going to give you a high-level demo, and I have about 10 minutes. Is that correct there, Travis?
I think you can take the time you need.
Okay, you bet. All right, let's go ahead. So this is Convoy. So the first thing that I would do is, as I mentioned earlier, right, it's a very simple command, right? So when you download Convoy, what you're going to get is you're going to get a cluster.yaml. So if I open up my cluster YAML, as you can see inside here, this instance here where I'm running Commander as my core distribution, I'm running it in Amazon US West 2. You can see that I have all the configuration. I've got the sizing of the EC2 instances, subnets, VPCs, all of that stuff is completely configurable. And then I can see all the add-ons as well too. So as I mentioned earlier, hey, if I didn't want to use something like Elasticsearch, I just changed from enabled from true to false. Convoy deploy add-ons if I want to enable it or disable it. And prior to running a actual instantiation of my cluster, I can disable any services that I don't want beforehand. So once that's completed, what you're going to see is your Convoy cluster. Whoops, excuse me. All right, this is the Convoy cluster. So this is the centralized UI. So the first thing that you're gonna see inside my Convoy cluster, this is just that Kubernetes cluster, and I'm running all the core add-ons that I needed. Now, once again, all those add-ons are all automatically automated and fully integrated into the Kubernetes into the Convoy ecosystem. So the first thing I can see here is I have my dashboard. I'm running Kubernetes 117.8. When I click on the dashboard, you'll see that it just opens up the actual Kubernetes dashboard. So this is great from an operation team. You don't always have to hand out a URL to multiple people and say, this is the URL for that one. The URLs are all built into that centralized dashboard. As we can see, I'm running a couple pods. I got a couple Nginx instances running inside this Convoy cluster. And if I also take a look at all my namespaces, I can see all my namespaces that I have inside this cluster as well too. and for all of its add-ons. The next area, as you can see here, we have dashboard for all the critical services that I enabled. So the first one, let's go ahead and let's take a look at our dashboard by Grafana. Grafana is going to give me the visualization to all of the monitoring of my entire Kubernetes cluster and all of its core services. So when we integrate this in, if anyone's ever used Grafana, these are user-defined dashboards. You build and configure these all on your own. The thing that we wanted to do was make sure that all of the critical, crucial services that you need are automatically integrated and dashboards are readily available. So as soon as you produce this to a line of business and give someone access, they have full access to all the dashboards. They're all pre-configured. So as we can see all of the Kubernetes. If we take a look at compute resources by pod, I can see all my pods within inside this Kubernetes cluster. I can also see, you know, things that like traffic, one of my core add-ons. Whoops. Right, let me click on that, sorry. I made a change, so sorry about that. I can see all of my traffic dashboard as well too. I can see response time. So from a networking perspective, if I have a networking team who wants to understand what is the performance, where are maybe some of the issues, what is the health, you can give them access to this Grafana dashboard without having to pre-configure it after the fact. It's all built in. Taking a look down at Kibana dashboards and all the logging is all built in via Elasticsearch, of course. One of the most common things we do here is, can I forward my logs into a Splunk? Absolutely. That's all can be pre-configured as well too within the cluster.yaml, just adding a couple variables into the cluster.yaml and having your Elasticsearch automatically port all of its logs up to your centralized repository. But by default, we provide all of the open source logging tools that you need, all cloud native capabilities for logging. So if we click on the Discover, you can see that I see all of my Kubernetes, right? I can see any possible errors, right? If I type that in, but I built a pretty nice cluster. So just a couple errors as of right now, and that's in my application pipeline. But the benefit here is that all of the stuff, it's automatically pre-configured right when you produce, once your Convoy cluster comes online. Let's take a look at a couple other items in here as well too. You can see I have some services that are grayed out, right? By default, I didn't enable these. I did not enable ITSEO or service mesh into this cluster, though it is available. I also have all of my Prometheus. So if I want to be able to set up alerts, I have critical applications. I want alerts to be scraped. I can come in and I can set those up, or I can come in and set up any other type of alerts that I may have inside here. And as you can see, it's a very robust list as well too, right? Container CPU load, right? Bring up the graphs, right? And I can see any of the graphs or any of the logging errors as well too. All of this stuff can be pre-configured, right? Set up your configuration. These are all the copy add-ons that you can add in, and you can also add these into your cluster.yaml for any specific applications. So if you have critical applications that you're going to bring up as well too, you can have them pre-integrated with Prometheus. Let's go ahead real quick, and I am going to move on from, as I said, quick high-level overview. Let me hide my controls, sorry. Let's go ahead and let's take a look at D2iQ Commander. So as I mentioned, Commander is what we feel is one of the things that is missing currently in the industry. How do I provide a single control plane for all of my Kubernetes clusters? How do I bring multiple different versions, multiple different clouds, and provide a central location for policy enforcement and service discovery, application lifecycle management, etc. So one of the things you're going to see here when you come into the dashboard, you can see that I have currently 5 clusters and I have 3 workspaces. So let's go ahead and let's take a look at the different clusters that I have in here right now today. I have multiple different clusters. So one, I've got an Azure AKS cluster. I can see that it's running version 116.10. I'm running an Amazon AWS cluster. I'm running that one in 16.12. I've got a GKE cluster on 16.11, and I'm running a production-based Kubernetes cluster on 117.8. I can import any of these clusters. It's as simple as just going in and clicking on Add Cluster. I can attach to an existing cluster. I can upload and create a cluster. So if I already have a Convoy cluster that you've certified internally, and you say, hey, I want to be able to give self-service to my developers, I can do that. I can upload this cluster.yaml file and automatically provision clusters for them. Or I can create other existing Convoy clusters as well too. To attach cluster, it's very simple. It's just copy and paste your kube config or upload one of the files, and you're able to set labels as well. Let's go ahead and let's focus real quick here in the last few minutes that I have here in looking at workspaces. So in multiple lines of businesses, you're going to want to be able to say, look, I've got a development platform, I've got production. I want to go into my production cluster. So one of the things that I have in my production is I'm running my Azure cluster, AKS cluster, and I'm also looking at my Azure cluster that I built, Convoy cluster in Azure. So one of the things that I can do here is I can create projects. And one of the nice things that I can do with inside the projects is I can create a project and I can call this whatever I want it to be called. So this one I just called Arkham Apps. And as you can see, I'm currently running Jenkins. So anyone that comes into the Arkham Apps, as soon as I import that cluster into here, it's automatically going to deploy Jenkins as well too, because I told it to say anything in this particular project, Arkham Applications, needs to be run in Jenkins. How I look at that is I can come into the view catalog and I can see that I have a few catalog items, right? I can deploy Kafka, Spark, Cassandra, etc. Let's go back to the production project cluster. I also want to show you a couple other things too. I've integrated clusters. I've currently only added in the Azure cluster right now, but I can also set roles and policies as well too. These are roles that I can configure to give specific individuals, like the Scarecrow admin. I've given them a specific role, right? With inside this role, I'm allowing them to be able to do certain things. When I come back into my access control list, I can select specific roles to provide them. Maybe I only want them to be a dashboard administrator. Maybe I want to give them full cluster admin role, right? When you come in, you can take a look. I can see that currently I can manage Kubernetes resources within that workspace. So cluster admin role, I can manage all the resources within inside that cluster for this particular project. Now, one of the beautiful things is that multiple clusters can belong to multiple projects, but this gives you the capability to also be able to ensure that, hey, I've provided centralized access to secrets. I've provided quotas and limits, right? With inside this project, I'm only going to allow you to use 8 cores, but you can request up to 20. Once I see that request come in, I can approve it and I can give you access to 20 cores. So it allows me to also be able to provide a level of multi-tenancy with inside this project. Now, real quick, I wanted to show you one other thing that we provide as well too. Every single one of these clusters, I want to have centralized monitoring and logging. Right? Wrong one. Sorry. I have 4 managed clusters, as you saw. The Azure, the 2 Azure, the Amazon East, and the GKE instance. I can see I have 4 managed clusters, and I can get full centralized logging and monitoring capabilities. Whereas if I deploy do-it-yourself Kubernetes, I'm managing each one on separately. Or I'm grabbing another open source tool and configuring and piping them into another open source tool to try and provide logging. Commander by default, once it's automatically added, gives you full centralized logging and capabilities just by querying those specific clusters. And then finally, one of the things that we wanted to be able to show you here today as well too was being able to show you Chargeback and Showback capabilities. Commander is fully integrated with KubeCost. So if you want to be able to look at, well, what's it costing me to run all of these clusters? How do I know my workload optimization is set to what it should be? How do I see some financial visibility, right? With inside the cluster, I can come in here and I can get a full overview of all of my services and based on what they're costing me. So right now, my overall infrastructure health score is 87. And how that's broken down is based on specific cost allocations. So when I come in, I can take a look at cost allocations and I can break it down into multiple variants. I can look at it via namespace. Maybe I want to look at it from a deployment perspective. What's it costing me per deployment? So obviously this is a small cluster, but what we can see here is my CPU cost just for running traffic kube add-ons is costing me $2.28. And I can break that down by also looking at savings as well too. So KubeCost will give you the capability with inside Commander to say, well, have I right-sized my nodes, right? Right now I know I'm spending $3,181. If I click on that, I can come in here and say, show that to me where I can make some optimizations. And we give you those recommendations. Hey, right now you're running M4X large, you could run more efficiently if you ran a T2 Nano for this type of workload or for this deployment. So I can see that I'm over provisioned and it's costing me greatly. Obviously, it provides health reports and a lot of other things as well too. But yeah, that's a quick high-level overview of the demo of D2iQ and Convoy and Commander. Obviously, we have more information on our website, and if you have any other additional questions, we'll be able to answer them at the end of the webinar, or you can hit me up in chat. And with that, I'm going to turn it over to Travis. Travis is going to give you the capability now to show you how you can do application migration workloads, enterprise disaster recovery, backup and recoveries for a Kubernetes ecosystem as well too. Thank you.
Thank you, Kirk.
Yeah.
I think the great thing around D2 operations is that having run Kubernetes clusters inside of production is something that I think a lot of people don't think about when walking into it. And so being able to take all these things in considerations is extremely important. I'm going to get my screen up if I can get you to.
Yep, I'll, sorry about that, full screen. Let me go.
Another thing to note while we're doing this is if you've got any questions or comments, please put them in the group chat and we'll be able to pull them from there for me or Kurt. And let me get my screen up. Also, I will be running a presentation, or sorry, not a presentation, a demo of the Kasten platform as well. So, okay. So part of D2 operations is also making sure that you can, so that you can make sure your applications remain available. And this is where Kasten helps to step in alongside with the D2iQ and Convoy. So what Kasten does is we have built a Kubernetes native data management system that focuses on backup and recovery, and that also enables application mobility and disaster recovery. So looking at the workloads inside of Kubernetes and being able to provide a data management layer that gives you the control that you need and gives you the flexibility, but focused on the Kubernetes specific viewpoint. So making sure that it's Kubernetes centric, that your workloads and the way that you're running your server and your applications and everything else are supported and maintained through the Kasten interface. So what I want to do first is kind of discuss a customer. This customer is Soprasteria. They're one of the top French IT firms. And what Kasten did for Soprasteria is that we actually went in and helped them with a few different things. But one of the scenarios that I want to look at with them is an environment that they had, a cluster that we helped them manage. And that cluster had 54 nodes, a fair amount of things happening inside of that cluster, 173 different applications, 415 volumes, and it was a multi-terabyte cluster. So what that broke down to as far as Kubernetes services is concerned is, you've got over 2,000 pods, 3,000 secrets. You have a lot of service accounts, you have configurations, you have a lot of different components that make up all of these different moving pieces inside of the Kubernetes ecosystem. And as Kirk was explaining, inside of like D2 operations, there's a lot in there in order to make sure that you are production grade, that you're ready to be able to take hits and keep rolling and keep your services up and available. And those pieces start to add up. On average, we end up seeing about 112 different components per an application. So with Soprasteria, the thing that they ended up really loving about the Kasten platform from Kasten is that we enabled them to be running, to have almost 700 developers to just 2 operations engineers working inside of their different clusters. And they also, the other thing that they really wanted is to be 100% transparent to developers. And so they were able to grab a very good ratio around the amount of developers that they could support and minimizing the amount of overall management costs as far as keeping things up and running. So another thing that that they use this for is migration. So they migrated their Kubernetes cluster from 111 to 116, and I don't know if many people are familiar with this, but being able to do a migration within a cluster is something that's very challenging. Being able to take all of the different pieces into consideration, whether or not you have APIs that have mutated or changed that you have to consider, and a lot of times it can be very difficult and something you don't really want to do in place. But using the K10 platform, Soprasteria was able to do that migration through us and make sure that all of their applications and everything remained available, and all of the data migrated according, and all of their applications were functional. So another thing that they are using, or that is unique about them, is their application diversity. So basically anything that you can imagine running inside of a Kubernetes cluster, they probably got it. They even have, COBOL, they've got PHP applications, you have Cassandra, MongoDB, Kafka, they have a lot of different services in there, and a lot of those are stateful applications as well. And so they are running almost everything that they can inside of their clusters to help create a manageable infrastructure for their teams. So what I want to discuss right now is why VM-based backups tend to fail. So if you look at like Soprasteria and other large organizations, a lot of times they have an infrastructure and different things in place already. And a lot of people ask us, well, why can't I just do what we have been doing? Why can't we just use our VM-based backups? So if you look at the way that services used to be built from virtual machines, you tend to have like a 1-to-1 ratio, where you have one application running on a virtual machine, and you may have some volumes attached to that. But once you introduce Kubernetes into this, then you start to lose visibility around the application. The volumes become attached to the application, and it becomes a little bit harder to track what those volumes are doing or what they're used for. Then once you transition into microservices, and you greatly increase the scale of what you're trying to do, you have a lot more volumes, you have a lot more applications running across a smaller subset of virtual machines. And then finally, once you get into Kubernetes and it's scheduling applications across your cluster, then those applications migrate around. They become a little bit more ephemeral, and the volumes that they are using and the data that they're using isn't necessarily congregated into a single location. And that makes it really difficult in order to know that if you're backing things up at the infrastructure level, that's great, but you lose that application-centric perspective. You lose the ability to back up and restore data specific to an application. And so that's where Kasten has really tried to come in and help solve this problem. So, so we kind of discussed these things, but I'm going to move on to the next one. So some of the solutions that our customers have brought up are, doing VM level data management solutions, but also what about just building a script? Why can't we just, put some script together that helps us maintain our data management? Well, this is great because you probably will tailor it specific to your application, but the problems around that is that it's going to be completely maintained and managed by you and your team. And as seen with like Soprasteria and some other customers, and even with like what Kirk was showing, as far as the complexity that you can get into is with multiple clusters and everything else, this ends up becoming extremely complex. And you end up being tied to your infrastructure a lot of times because you're trying to build something as quick as possible to maintain that. So it becomes much more burdensome to the team than it needs to be. But then what about like storage overlays, backups, or migration? So the issue that we see here, like it ends up being not quite what you're expecting. So there tends to not be any fault toleration. It tends to be much more complex as far as management is concerned. And the performance cost for those overlays is significant as well. So we don't generally recommend using the backup system of storage overlays. So Kasten has taken a different approach. What we have done is that we have built a system that'll go in and do some self-discovery around the services that you're running, and it'll go and grab all of the different components. And those components can be persistent volumes, but they could also be configuration, they could be secrets, they can be even ingress or even custom resources that you are running inside of your cluster. Now we have worked to abstract the underlying infrastructure layer. What this means is that we can support a plethora of different storage systems, as well as data systems and across clusters, across regions, and across multiple clouds. And then also, we have built this solution to work with the applications in a Kubernetes-centric way. So when a application is going to be restored, it has to be done in a way that you're working along with the Kubernetes scheduler in order to make sure that things are spun up in a proper order. And so when we do restores and things like that, and we make sure that those operations are coordinated effectively. So our K10 platform, we have built it to be very application centric and very simple. And it is software only. And it also has been built with end-to-end encryption, and so it's also secure. And so everything that you're backing up is encrypted, and it is kept safe from any prying eyes that are trying to get to it. So it is a very operational focused platform, as we have very much tried to make it easy to use, and we have also tried to make it very developer friendly. Like, they don't have to get in and understand a whole lot of what's happening behind the scenes. You can just get them onto the platform itself to be able to see and know that their applications are being backed up, or how to be able to restore them. And so what I'd like, sorry, one more thing. So this is kind of an overview of what the application is, but I'm going to jump into a demo real quick. Hopefully I've got a little bit of time here. Sorry, I'm going to jump through these for the demo. So I've got a cluster already running. This is a cluster that's been built with Convoy, and we are running an online store. So what I'm going to do within this demo is I'm going to add a couple of things to the cart to be able to simulate, data that we're trying to keep. And so I'm just going to add a couple of things here, and we can see now that we have a cart, and we have our metal camping cub and our barista kit. And through the Kubernetes dashboard, I'm going to walk through what the dashboard looks like and how that interaction looks. So we're going to go look at this application specifically. So we have our marketplace here, and you can see that we've done some auto discovery already. So we have a volume, we have different workloads running in here, and we have networking resources as well as configurations all tied to this application. So we're going to go in and generate a policy, and the policy is a way for you to be able to manage your applications in an automated fashion. And a policy can be run in such a way to where you get a lot of control of how that policy ends up running. So you can change the frequency, and you can also change the retention. So if costs are a concern, or if you want to make sure you're keeping your costs lower as far as the data that you're backing up, you can come in and change the retention in order to make sure that you're backed up and you have their data there, but in a cost-effective way. So also you can enable exports. And so what this will do is it'll do the snapshot, but it'll also export that out to a separate location to keep this extra copy, which enables data mobility, but it also allows you to keep a separate copy just for disaster recovery scenarios as well. So within the K10 platform, you can choose how you want to back up an application. So right now we're doing it by name, which means that we're going to look at this application specifically, but you can also do it by label, which allows you to back up things that, anything that is Redis based can be backed up. So this allows you to do multiple applications with a single policy, but we're going to stick with just having the specific application backed up for now. Then on top of that, looking at a full application or at multiple applications, you can filter out the resources that you want to include or exclude. And so if you only want the data backed up, you can add a filter to only include that. Or if you want to exclude like certificates because you have a different way of provisioning those, then you can exclude those as well. So we're going to do all resources, and then I'm going to create this policy here. And you can see that I have a policy for my marketplace, and we're going to run this. And once that runs, we're going to jump over to the dashboard, and this will kick off a job. We see it's already running here actually, but you see within here that we're capturing a lot of the different artifacts, and this is going to take a second, but I'm going to jump over the slides real quick. So while that's running and doing our backup, let me jump back over here and kind of discuss some of these slides that I had to jump over real quick. The K10 is built, again, to be very agnostic to the storage infrastructure. So you can bring the storage infrastructure that you're using, whether it's a CSI-based or different storage infrastructures. We also, well, obviously you're tightly coupled within the Kubernetes ecosystem, but as far as the distribution is concerned, we're compatible with a lot of different distributions, such as D2iQ Convoy, but also Google Kubernetes Engine, Amazon EKS, or just a plain old cluster that you spun up yourself as well. You get the flexibility there. Then finally, the data services, we couple into those data services as well to be able to provide you the best in class support for those. So you can do them from a high level, but you also can get very close to the application and get that application specific workflow if there is a workflow that you are using already for your applications. So then, a little words about this application. So it's a polyglot application. It's got a lot of different things running with a lot of different languages. And it's pretty complex, which is a reason why we like to use it as part of the demos. But one more thing about our architecture, and then I'll jump back to into the dashboard to see if we've got the backup running or finished. But our K10 platform, it integrates into the orchestration platform, so into Kubernetes, and we are coupled with that. So that means that you can use the tools you're already familiar with. You can use kubectl or anything that you're using to help maintain the Kubernetes ecosystem. So the custom resources that we have in there are actually just custom resource definitions inside of Kubernetes. Then, you get the options of how you want to manage your data on the back end. So that infrastructure layer is completely up to you, but we have support for block, object, and file storage, and really any kind of virtual or physical infrastructure that you plan to maintain. And then finally, that application-centric view. K10 has an extensible side to it that allows you to specifically build backup and recovery solutions for your applications, or to use more generic ones using snapshotting. But those application blueprints give you the control and the flexibility that you would want. So I'm going to jump back over real quick to our dashboard and see what we've got going on here. Looks like we're still running. Okay. So some features that we have inside of the K10 dashboard is, so we've talked a little bit about the data operations. Let me just pull these all up real quick because I think that we're running out of time. But the one that I really wanted to highlight here is kind of the operational support. So we have logging, we have monitoring and alerting all built into the K10 platform so that you can know when things are going well or when they're not going well. And you can set up the alerts and the notifications necessary in order to make sure that your data is being backed up efficiently. And let's see, I'm wondering if, I'm wondering if this is going to finish in time. Oh, it takes, I think last time I ran this, it took about 2 minutes. And so we're about 1 minute and 20 seconds behind. I do have another one that I think that we'll just go look at that real quick while that's finishing. But once that's done, what it's going to do is it's going to generate a restore point. And from those restore points is where you can actually restore your application. So looking at this restore point, it'll give you a lot of options for you to be able to you run this restore. So you can do it in place, which is what we would be doing, or you can even spin it up into a new namespace if you want to be able to try an upgrade or demonstrate something else on that same application without affecting the one running in production. So we have hooks as well, so you can do on success or on failure. So if you do want to get someone paged when something doesn't back up correctly, you can add some hooks in there to be able to add custom scripts. Now, if you're only looking at the data on the restore, you can choose that. If you want to apply a transform. Now, using the transform is how Soprasteria was able to do the migration. So what this means is you can even move from one storage provider to another storage provider. So we help, or from one cloud to another. So we help build that platform in there to give you that agnostic flexibility to what your infrastructure is. So you can even come in and you can custom choose like what parts of the application you want to restore. Now, if you have a piece you don't want to cream, you can come in and remove that and it won't be restored as part of it. But the idea here is that it gives you the flexibility. It allows you to control, the way that you're doing your backups and the way you're doing your restorations, and it allows you to cater the solution to your needs. So I think that, okay, we did finally get through that, but basically all I would do after this, which I think that we're out of time now, but basically what I would do from this is just run that restore to be able to show you that the cart being creamed and then the data coming back. And so I think I ran out of time there, but if there are any questions or anything else, I think we can open up the time for that.